All right, guys, welcome back. We are in part 3 now of our section 1 of chapter 1 here in our pre-calculus full course series. And we are jumping straight into intervals and exploring interval notation rules. So let's take a look at our visual here. And let's note that an open endpoint, that's parentheses, means the endpoint is excluded. Here we can say both A and B are excluded, so we're using parentheses for both. And a closed endpoint, we use brackets. Here we can see both A and B have closed, so they are included. So the parenthesis, whether it's open or closed, means that if the endpoint is excluded, whether it's the beginning, whether it's the beginning or the end. And our bracket, whether it's the beginning or the ending, means the endpoint is included. Now, infinity and negative infinity will always use a parenthesis because infinity is not a number, it's a concept. So let's take a look at our third example. We see that we would have A is included because it has an open, or the beginning, I should say, so I don't confuse the terms here. But this begins or opens with our bracket, so it will be included, but it ends with the parentheses, so that will not be included. And we can see here A is included, B is excluded. And the other way around, let's look at that, where A would be excluded and B would be included. How do we see that on the number line? Open dot, open circle point here on A, closed on B. Let's take a look at the next one. We have excluded A, infinity always excluded there because it goes on forever. It's a concept. So we just want to make sure that our array here on the line would be open A. Our next example, same idea here, but A will be included. So we'll use a bracket. Next example, negative infinity B, infinity and negative infinity, always parentheses. There we go, B open, excluded, going to the left infinitely because we have a negative infinity that we begin with, and we have a negative infinity we begin with in the next example with B being included. Same idea, but we'll close in our dot. And then we have negative infinity, infinity. This will be the set of all real numbers, so it goes on and on. It includes every point there. Again, infinity and negative infinity will always use parentheses. It's a concept, not an actual number. So in other words, our last example are all real numbers. It includes the entire number line. So we see here that interval notation is a compact way to describe any continuous range of real numbers. The bracket type at each endpoint tells us whether that endpoint is in the set. Infinity is never enclosed in square brackets because infinity is a concept, not a number. You cannot include something that has no defined value, in other words. All right, before we go to our example, let me ask, how would you write all real numbers greater than or equal to 5 in interval notation? We'll keep our visual here to the right. So in that case, we would include 5, greater than or equal to 5, and put the infinity sign to the right, and then of course that will have a parentheses for the closed parentheses. So classic student error will be to put a bracket here, closed bracket, but we don't do that. Parentheses always for infinity. All right, there's a round parentheses for infinity. Similarly, negative infinity is always preceded by a round parentheses. Now let's go to our example. Example number 5, graphing interval. Let's start with A here. Describe the graph of negative 1, 2 on the number line. So we have a closed filled circle at -1 because -1 is included, with our open hollow circle at 2 because 2 is not included. So a solid segment connecting them together. Now that corresponds to our inequality here. And the way we would say that in words is the set of all x such that -1 is less than or equal to x, and x is less than 2. All right, so closed circle at -1, open circle at 2 on our number line, corresponding to this inequality. All right, let's take a look here at B. We have 1.5 and 4, both are included. So we have our closed or filled points at positive 1.5 and 4, making that segment. Here is our inequality. We'll read that as the set of all x such that positive 1.5 is less than or equal to x, and x is less than or equal to 4. All right, let's take a look at C now. Here we see -3 excluded with infinity, positive infinity here to the right. To the right, we'll be writing positive infinity. To the left, we would write negative infinity if we had a negative infinity, but here we have a positive infinity. Let's look at the graph really fast. -3 is excluded, so we'll have that open dot, and the arrow will go in the positive infinity direction on and on forever on our graph here, our number line. All right, so open circle at -3, arrow pointing to the right, and let's take a look at our inequality. And we'll practice saying that the set of all x such that -3 is less than x. All right, let's go on to our next example, example number 6. Finding unions and intersections of intervals. Let's take a look at A. All right, so the intersection of two intervals is the set of numbers that belong to both intervals simultaneously. Geometrically, this would be the overlap region on the number line. So here, which numbers are in both 1, 3 with our open and closed parentheses, and 2, 7 with our open and closed brackets at the same time? So here we have numbers greater than 1 and less than 3, and also greater than or equal to 2. So let's write that out. For our inequality, now our 1, 3 requires x to be greater than 1 and x to be less than 3. And our 2, 7 requires x to be greater than or equal to 2 and x less than or equal to 7. Both conditions would be x is greater than or equal to 2, more restrictive than x is greater than 1, and x is less than 3, which is more restrictive than x is less than or equal to 7. So our result is, let's write that in red. Open bracket, 2 included, 3 excluded, which means x is greater than or equal to 2, but less than 3. Now, how do we graph that? This will include 2, but exclude 3. So we would want to include 2, but exclude 3. And there's our segment. Let's take a look at B. The union is the set of numbers in either interval or both. So which numbers are in 1, 3, and 2, 7 here? Any number greater than 1 from the first interval, which starts at 1, right? And then through 7, the right end of the second interval. So the result would be, let's write that down, open parentheses 1, And then we'll close it with the bracket. So we have our what's excluded and what's included. Now, in inequality form, we understand this to mean that x is greater than 1, but less than or equal to 7. So, when taking the union of overlapping intervals, the result is a single interval that spans from the smaller left endpoint to the larger right endpoint. Students will sometimes try to list both intervals separately when they overlap. But the union of overlapping intervals is one continuous interval. Now, how does that look on our number line? Here we can continue on to 7, 5, 6, 7. Let's take these off. And we will exclude 1, have that open dot, but include 7. And there's our segment. Here we can see the visual down here. Looks a little better than what I was drawing, but there you go. All right, that will conclude it for today's part. In our next part, we will jump straight into absolute value and distance. We'll see you soon. Bye.